So finished up last time with 12 failing tests, STA, STY and STX instructions. So we didn't write any code to actually support those, and that's what I'm going to do this time. So you can see the 12 failing tests that I've got on here. So let's just jump right into that and get that done. STA Zero Page, why not? Let's do it down here. So, STA Zero Page. So in effect, what we want to do is use our addressing modes that we used before that we set up. So we have like address mode 0 page there. So it's the same thing really. Again, we're repurposing code. We need to get the address that we want to write into. It should work the same way it works with the other instructions. And then we just want to write an 8-bit value to this address. So we need a write byte function. And in this case, it takes it from the A register and puts in there. I think it needs the it will need the number of cycles, the address, and the memory, I reckon. Yeah, so let's just implement that, because we had lots of like read word and doing all this that, but we never actually had anything that could actually write. Yeah, so let's do that. So in effect, this is we write a byte. So we want taking the cycles. We want the address. And we want the memory. So this is exactly the same as the other ones. Oh, we need the byte as well. And I think actually this would be, would it be that simple? And we subtract a cycle. And we don't return anything. Wow, that's maybe too easy. Let's just see if that works. Well, I've got 11 failed tests, so I think something worked there. Let's go back to the... Yeah, so, I mean, this would be the same for STX Zero Page, except it would do the X register, and STY Zero Page would do the Y zero, STY Zero Page, do the Y register. 9 failed tests, yeah, that's how it works. So let's do the rest of the, well, let's do everything that's 0 page. Oh, let's do absolute next again, because everything's got an absolute addressing mode. So we could just really maybe copy this, and this would be absolute, STX Absolute, STY Absolute. And we want the addressing mode absolute, absolute, absolute. Oh, that might be the quickest I've done one of those. Is that actually it? Because now we've got so much code that we can reuse. Yeah, down to 6 failed tests. That was quick. So everything starts getting a bit different. Let's do STA Zero Page X. Let's copy this one. STA Zero Page X. And that's that. This is great having all the code already to do this stuff. That's down to 5, and we have STY Zero Page X. So I think that's the other one. So again, that's the same with STY Zero Page X, and that does that writes from the Y register. Oh, yeah, is that right? Addressing mode 0 page X. Down to 4. So that was quick. So now it's just, again, what's left with, it's these last 4 instructions that are left on this store accumulator. We need to do, we need to implement those. So STA Absolute X. Do we have an addressing mode Absolute X? We do. And that stores in the A register. STY Absolute. Why is it complaining about that though? STA. Oh, is this just gone a bit mad? Int STA Absolute X. Oh yeah, because I've actually defined these as the wrong names. Yep. So these tests were actually wrong. STA was wrong. STA, that was wrong. STA, that was wrong. And STA, that was wrong as well. It was hard to tell they were wrong though because the tests were already failing, so we never really got past that. Let's see how far we got now. We've still got 4 failing tests. STA Absolute X. Now I've just done that one, so what's wrong with that? STA Absolute X. So this one's not working. STA Absolute X can store the A register into memory. STA Absolute X, right, okay. So have I written this test wrong? Oh, what was actually failing about the test? That's a good point. Instruction 0 not handled. Am I executing too many cycles? 5 cycles for STA Absolute X. Let's just have a look. No, that's right. So something's definitely wrong there. Is absolute addressing X not working? That's the right address. And then we write the A register into that address. Oh, and then there's still a cycle left. Why is that? There's 5 cycles to do this. So we've not consumed enough cycles on this one for some reason. Maybe just because there's an extra cycle taken for this that I'm not really getting from this. Let's try that again. It may be also, this one doesn't mention that this can take different numbers of cycles, and this appears to be taking, we're on 4, we took 2, I think we are missing a cycle on that, because you have to add this X on, and then you have to possibly do another instruction as well, which would take you to 4, and then another one there. That is interesting. It's not consuming enough. Let's run it again. So we'd consumed 1, we thought it was a 5, we consumed 1, we go in here, we consume 2 more, it takes us to 3, and we consume the other one, and that's writing the byte into that address, and that is, does write byte consume 2 when it's not in the 0 page? Is that what goes on here? Maybe that's how that works. These previous ones have been 0 page ones. For now, I'm going to assume that that's true. And so we'd say if the address, it consumes a cycle, and if the address is greater than FF, then it also consumes another cycle. So I don't know that that's the way that write byte is supposed to work, but it might be. It's going to make this test pass though. Oh, it made more tests go wrong. So this is where the unit testing part comes in, is that you start unit testing something and you think you fixed one thing, but actually you broke something else. So store accumulator. Yeah, so that's breaking the other tests. So that can't be right. So this is an odd one, so maybe for this one right now I just have to consume another cycle, but I don't know where that cycle would have gone. Oh, I've still got 4. STA Absolute X. What is going on here? Let me just run that again. STA Absolute X instead of the original. Expecting. Oh, so it didn't load the correct value. Really? STA Absolute X takes the 8000 value, adds the F onto it to get to AF, and it stores the A register in there. Which is right, which is 8000 and F. That's 8000 and F? Why are we not? Let's look at the memory window. There's the 42, and there's all the cycles being consumed. So what was wrong? What is wrong with you? STA Absolute X can store the A register into memory. AF is 0. What? Why is it 0? Is it this test is not working? There's something odd going on here. Oh, wait a minute. Oh, you idiot. It is wrong. It's that. Absolute X. Yeah, it stores in 8000 and F. Oh, what was I doing? What was I thinking there? Yeah, that's more like it. 3 failing tests. And we've got an absolute Y, which is pretty much the same. Also don't know why that cycle has to be consumed. We've got an absolute Y. Again, there's this extra cycle thing in here which I don't think applies to this instruction. So that's pretty odd. And I need to put another to do in here. So there's a question over that, and there's a question over the same thing on address Absolute X. I think they may be wrong, those. I think I've got this test wrong again, haven't I? Yeah, because they were copied and pasted from each other. This is the wrong test. So 8000 F. Again, I could have like rewritten that test, but there we go. Right. We are getting somewhere, I think. We don't know if it's the right place, but we're definitely getting somewhere. Indirect X and indirect Y. These are don't think we have. Yeah, I don't think I've refactored those out actually. And I think we've got this. I think we've got similar instructions up here. Yeah, these ones. which is this is how indirect X works. So maybe it's time to factor that out. I'll just copy it for now. And instead of reading a word here, we are going to write a byte from the A register I think that's right. STA Indirect X can store the A register into memory. Oh no, I need this bit as well. So this is probably a time to factor that part out. Yeah. So let's factor this part out. This is indirect X addressing. Where do I put this? And it's also called indexed indirect. So we can actually factor that out now. Which takes cycles and memory. Gives you back an address, I think. Same thing there. Phew. Conversion loses qualifiers on what? Oh, we didn't return that value for one thing. Read word wants to be const memory because it is, yeah, it's another one of these const things because it's doesn't need to be, oh, and then read by also wants, because we're just reading from memory, we don't ever actually change it. Right, down to one test broken and we've refactored even more code. I think it's this last one here, isn't it? Yeah, it's indirect Y. So again, I'm going to do the same thing again. We copy and paste to start with. And this is store accumulator indirect Y. And instead of that at the end, it wants to write byte. Accumulator so this is the part that wants to be refactored. So it's indirect Y. Right, I think that's that put into its own method now. So now I've just got to use it. So there's the load version of it. the store version of it. So I think we might have some problems with cycles going wrong here. Oh, this one didn't work though. STA Indirect Y can store the register into memory. It's definitely there though, so what didn't it like about that? It didn't consume enough cycles again, did it? Because this looks like this one's always gonna... Is this consuming an extra one? Yeah, we've got this one cycle left over. We've got the same problems as before, really. We've got this and this extra cycle stuff going on in this one. So there's another to do on that. Let's just see if this got any better. There we go. So we've got all those tests working now. We've technically implemented those instructions, but there's a lot of to-dos left in there. It's quite possible that we've done some things wrong, but at least we know we've got something working, and that these tests are definitely, like, they are loading memory in some situations. They are storing to memory correctly in some of the situations. So that's definitely very good. It's a very good start, but we've got a lot of to-dos going on here. And we've refactored more code, so we're reusing and reusing and reusing wherever we can. But this is just basically a giant switch statement now. I mean, maybe it was a bad idea to do this cycles thing where I'm trying to take a cycle everywhere I think one is, but quite often I'm not sure why a cycle is being taken. I don't know why an extra one is needed for this. I mean, maybe this website's wrong. This is store indirect Y. This is just 6. But I could only count 5 where I would actually consume them. So maybe I am missing something in here, maybe. But that seems to break the other tests when I do that. So I'll leave it the way it is for now, because it's working. But clearly there's more tests need to be written to get this working correctly. So we might do that in the next video, maybe try and do some cleanup on this. Before we move on to doing even more instructions.